Right.
A pre-show. So, Josh, I have a hypothetical question for you. Suppose, hypothetically, someone had, a few months ago, had a C2 to C5 fusion. That's the second through fifth vertebrae in the neck. And this person, for some reason, is now unlikely to ever get low and flat on a bike ever again.
Oh, man.
This person probably can't get into the drops anymore due to a reduced range of motion in this hypothetical person's neck. Okay, now this hypothetical person deeply cares about racing and being fast, but has to sit more or less upright now. What could this hypothetical person do, hypothetically, to still cheat the win?
Oh, Fatty, is this person you?
Look,
and I already know the answer to that this person is definitely you. And
yeah,
oh my God,
it is
I'm
me.
sorry.
No, I mean, yeah, you get old. I didn't have a bad accident or anything. It's just stenosis and a lot of wearing myself down, and I feel great. The reasons I went in to get a C2 to C5 fusion are, those reasons are no longer there, which means that the surgery was a great success. I feel great. I'm going to Italy to go riding next week. So, I mean, things are going good, but it's going to change not just how I road bike, but how I mountain bike.
Yeah.
So I'm curious, as a person who loves marginal gains, and, I'm going to be riding more or less upright. What can I do?
Right. Oh gosh, yeah. I mean, the hard one with this one is the neck bending, right? I mean, which is kind of obvious, but so many of the tricks, right, are we can rotate the rider forward around the pedals, but of course that puts all the strain back in the neck. You can lower the front. So yeah, this one really breaks all the kind of traditional wisdom. I'll say, I'm going to assume your up position is going to become relatively fixed around, kind of what angle your neck can support and handle. And,
yes,
I think it's a relatively fixed torso angle, relatively fixed head angle. I think clothing is going to become ever more important for you. The tighter the better for these more upright positions. I mean, as I think about and even beyond the racing, I mean, it really could become a good opportunity for like a small fairing. We've talked about like the zipper fairings and things in the past, but that, we certainly see in the wind tunnel, you put something like that in there, and I mean, my goodness, it can be a 40, 50 watt advantage. And of course, you're kind of using it as more of an offsetting factor, right? It's right. You're kind of using it to get back to that CDA that's not attainable. And and then my other thought on it, and because this has been recent in my own life, is what about an e-bike? Rico and I just bought an e-bike to commute to work, I don't know, a month ago, and I don't think I've driven my car since. But I've got this awesome basket for him that he like sits in front of the handlebars and just like loves his life the whole way to work. And, aerodynamically, like our whole setup is a brick, but the e-bike, that nice Bosch motor overcomes a lot of that. And so, I can literally run into the fast local group ride on my commute home and hang with those guys for like 15 or 20 minutes and have a conversation. And I have like a little 12-pound dog on the handlebars and I'm in my work clothes. And it's a ton of fun, and everybody gets, I think there's enough acceptance now around the e-bike that people are just cool with it. And, when they know you and they know you're not some random person showing up. Those would be my thoughts, but I'm so sorry for your surgery, but so glad you're feeling better. That's.
I mean, I'm doing great. I'm one of the lucky ones. Because my quality of life is up, I would say 20%. Right?
Wow, that's great. That's fantastic.
Full range of, I have the use of my right hand, which was kind of a question mark for a bit. No, so I'm doing good. I will say that the e-bike and your little dog Toto on on your basket, I was definitely getting a vibe of the opening of Pee-wee's Big Adventure. I don't know, featuring the the late great Paul Rubin. But, But yeah, so it's I just the fairing idea I love. I don't want to go e-bike yet just because I still want to race and I still have the legs, I still have the lungs.
Yep.
And so e-bike, I'm not ready for it. It's just it's like I'm just sticking straight up. I'm sticking up as straight as a person can stand right now. So something I'll be experimenting with. Probably bring this question back later.
Yeah, no, that's crazy.
All right, so that's one for the YouTubers. I would love to get. I know that out of the three of us, two of us have had cervical fusions, unless all three of us have. I don't know.
No,
about
but
you, Josh,
my wife had one like 7 months ago.
So
although
it's
hers
incredibly
was
common. Is the thing.
Hers was low back, but I mean almost the exact same thing. I think they fused 3 vertebrae, took out 2 discs, and it's just like magic. I mean, her pain went from 9 out of 10 to like 1.
I'm at a 0. I haven't needed to take even ibuprofen in weeks.
Wow, that's
so
amazing.
It's great. It's definitely worth it just for quality of life. Maybe YouTubers. I mean, I was kind of thinking it is so common that probably there are people who are also thinking about, I don't have flexibility because for surgical reasons now, but I still want to race. And I would love to hear what people are doing. So, let's look for that in the comments section. Should we do a show?
Sure.
Let's do a show.
You want to do the clap?
Yeah.
Oh, yeah.
Let's do that. Let's do that part too.
All right.
Ask Josh anything at number 31, show 101. In 5, 4, 3, 2, 1.
1. I feel like I jumped the clapping gun.
You did. Okay.
It's always so hard to tell. Like, was it lag or was I just off or both?
All three of us.
I got to feel like sometimes the lag works in my favor. Like
I think Hottie
and laggy.
Hottie does like 5, 4, 3, 2, 1, and then he waits for 4 seconds, and all of a sudden, I'm like, God, he's just trying to make it so we miss.
It doesn't have to be that precise. I get the files lined up. As long as I can kind of see where it is, then there's a lot of shuffling and shifting after that anyhow. So, but it does save time. It saves 5-10 minutes, 5 minutes from going, where did this whole show start? So it does save a little bit. Okay,
that clap is a marginal gain, dudes.
It is.
Yeah.
It is a marginal gain.
Yeah, that's real.
Okay, here we go. This is the Marginal Gains Podcast. Ask Josh Anything, number 31.
And we are jumping straight into listener questions. I know you thought I was going to cut the line, but I wasn't. This time, we are starting with what I think may be the most marginal gainy question ever. This one comes from one of our listeners, and it's about chain guards and marginal gains. Miles texted this question to our hotline. Given the significance of chain friction to RR, I assume RR is rolling resistance, right?
Yeah, let's assume that.
let's assume rolling resistance. And the significance of debris contamination to RR and drivetrain life, why don't we see more chain guards in performance bikes? I would also think there would be an aero benefit to this system. The question is coming after a trip to Amsterdam and watching a Mike Burrows documentary on YouTube where he talks about the aerodynamic benefits of chain guards in his high-performing bike designs.
Yeah, it's
why
an
no
awesome.
Chain guards, Josh?
It's an awesome question, and I mean, if you look back at the history, people played a lot with this in that crazy kind of like 90s period where we went from the Lotus to the Pinarello Espada, and Cannondale had some stuff, and you just had all these crazy designs. I know Mike Burrows, who did the original Lotus design and did the original giant compact geometry, and then so many other really like industry changing, groundbreaking designs. Mike was a huge believer in that, as his other big passion was single-sided forks, which you notice in a lot of his, certainly concepts and even some of his bikes that made it to market. But I think the big answer ultimately here is that post 96, 97, when the UCI changed all the rules, really all your opportunities to do anything here became illegal. So I think people were doing a lot with it. It absolutely worked from an aerodynamic point of view. And, I think knowing what we know now about chain friction and drivetrain losses, it could only help with those things as well. We weren't paying nearly as much attention to that in the 90s as we are today. I mean, we weren't paying as much attention 10 years ago as we are today. But knowing the benefits of a clean drivetrain, and knowing that drivetrain losses due to contamination and dirt over a single Tour de France stage can be a couple of watts. And so, over something like a Paris-Roubaix distance or whatever, it could probably be 5 to 10 watts at the end of a Roubaix, having a encased drivetrain versus an exposed one. But ultimately, like so many good things we could have had in life, the UCI is involved, and this is why we cannot have nice things.
The UCI is why we can't have nice things. That is our next T-shirt. I love it.
Yeah.
So when you talk about an encased drivetrain, I'm trying to decide whether you are talking primarily about just a chain guard, or are you is there a world where you can encase more than that?
Oh, yeah. I mean, I think you look at some of the concepts and I haven't had any time to, I should go research this. We should find it for the YouTube channel. But yeah, I mean, there were people, with the advent of carbon, you could all of a sudden like have these hollow structures. I mean, you could put your whole drivetrain in the frame, or at least have it encased in some sort of enclosure where, maybe the frame itself has a little bit of a, kind of a concave section that, your drivetrain kind of fits up against, and then you put sort of a cover over it. I think these things, in a lot of cases, probably become nightmares for the mechanics that have to work on them. But yeah, I definitely, we had prototype track bikes, and I can't think of any of them offhand. I want to say that, like, I think Gucciodi had one. But there were a number of systems where you were either some combination of like crossing through the frame with some sort of fairing type geometry, or more or less fully encased in some sort of thing that was accessible with, little hatches or removable bits. But yeah, I would think of, this is, like if you're into old airplanes, right? You think of there was this period in the 50s, and the British in particular. You had the V bombers and these kind of like early commercial aircraft, and the engines were in the wings, right? And you look at it now and think, oh, it looks so modern, and the faired wing, and of course we stopped doing that for maintenance, and I mean there's a number of reasons, but the reality is like you got to take half the wing apart to work on the engine now, and so that's another reason that this design probably hasn't further gone in that direction. But I think the reality is nobody's going to spend the money to even bother trying when they know that there's no real commercial feasibility for this product in the types of events you would want it used, right? We're going to make the most aero bike in the world, and you can do everything with it except race it anywhere. And that's, I mean, we're an industry that makes a lot of poor business decisions, but that one's pretty obvious even for the bike industry, that like, we probably shouldn't do that. But no, we'll dig up some pictures, and we can certainly maybe hit those in an additional clip to the YouTube channel or something. But there, some people, including Burrows, have done some really cool stuff there. And I think if you let your mind run wild, it becomes even crazier.
And that is what we do here. The Marginal Gains Podcast is presented by SILCA, Heritage Pumps, Wax Chains, Aero Socks, Bike Cleaning Products, and exceptional chain guards. No, okay, not that yet. I'm Elton Nelson, also known as Fatty.
I'm Michael Houghton, Hottie the Most. Marginal Gains also supported by Shimano. It is a little-known fact that Shimano actually has a sister brand that makes helmets. And not just any brand, it's Laser. Like Shimano, Laser is always looking for ways to improve, which is why they have recently introduced Kineticore, a rotational impact system that they developed themselves. Kineticore-equipped helmets have already received 5-star status from Virginia Tech's Test Center. There are a handful of Laser helmets that come with Kineticore, but the one Marginal Gainers will most likely be interested in is the Vento, an Aero Road helmet. The entire Laser lineup can be found at lasersport.us. And a quick note, folks, on this podcast, and a nice milestone that occurred with our show. We have now put out 100 episodes as of the last one, the Super Dave episode and his Strom Cycles team. That was our number 100 episodes. Pretty cool there. And look, folks, there are 4.2 million podcasts in the RSS world, but only about 300,000 that are actually regular shows. So congrats to us for keeping this thing going. And another number that may be more impressive than the 100 episodes, and that is 1 million. You see, shortly after we put out number 100 episode, this little show surpassed the 1 million download mark. So congrats to us on that, and thanks to our listeners for your loyalty. Good numbers there, guys.
Absolutely. I gotta admit, guys, I listened to each episode around 7,000 times, so
I knew that was
bogus.
I just have to say huge thanks to both of you guys, because I am notoriously busy and behind the 8 ball on this, and so I think if it weren't for you two keeping me in line and just putting the schedule on my calendar, I think we would be on like episode 7. So you two really make these happen, and I just get to show up and answer the questions. So I thank you so much for making it easy for me.
I love doing this show. It's a lot of fun, and we get to ask weird questions about whether drivetrains need aero guards. And now I'm thinking about, man, the cassette. There's an aerodynamic disaster, right?
Yeah.
Oh man, never thought about that before, and now I won't be able to think about anything else.
So truly one of the coolest products I ever did. Right after SRAM bought Zip, they have this internal gear hub business in Europe based out of the Schweinfurt facility, and actually got a 9-speed internal gear hub and built it into a Zip disc wheel, thinking like, this is the future. And if you remember, about the year after they acquired Zip, they launched a mountain bike product called the Hammerschmidt, which is like a planetary gear crankset.
I remember.
And so, do you remember that? And so
Yes.
we actually had a TT bike at Zip that was a Hammerschmidt crankset with this 9-speed IGH rear hub and a disc wheel. So it looked like a single speed, and was actually a 2x9 drivetrain. And then I had all my hopes and dreams crushed by the realities of the efficiencies of planetary gear systems. So it was like, it would need to make negative kilogram of drag to actually offset its own efficiency losses. But man, it looked cool. And yeah, there was a good probably 2 months there where I'm like, no, we can get for the record, theoretical efficiency of a planetary gear is like 92%. So 8% losses, that's hard to swallow. And obviously when you have it at both the crank and the rear hub, you're doubling your losses. Anyway, good times. But
good times, and this is something I want to go into more. I mean, we're always talking about how aerodynamic the rider is and the bike as a whole. Just starting to think about the little pieces, right? I want to do a show on this, right, where we stack rank the aerodynamic efficiency of each part of the bike. That's an episode coming up soon. But
let's
today,
do it. Yeah, we have all.
Here's a phrase for Marginal Gainers: centripetal forces. This was used in a question left in the comments section by Brian Larson, who says, "We know that we need to account for micro irregularities on any velodrome, but how do we account for the banking? I can't help but imagine that the forces during banking is incredible. And as such, this has to influence CRR or effective rolling resistance. Brian wants to know when and how do we account for centripetal forces applied during velodrome testing and modeling, and how does this affect CRR? So Josh, is it centrifugal forces or centripetal forces, or both, that we need to account for?
Ooh, that's them's fighting words for a lot of people in my world. That's a great way to phrase that. Yet technically, it's centripetal acceleration, and the way to think of that is like if you have a weight on the end of a string and you're swinging it around. It's the tension in the string, essentially, is the centripetal force, as people call it, or it's really an acceleration. The centrifugal force is, you think of like Newton's third law, every action has an equal and opposite. Centrifugal force is a imaginary, not a real thing, and it is the opposite of the centripetal. It's the so-called force that it feels like it's flinging you radially outward. Except the reality, and this is where like the physicists and some engineers get just super cranky about this stuff, is there is no radial outward force, because what's really happening is the object in motion wants to stay in motion going straight, and this other force is actually pulling it towards the center line of the turning radius, right, about which it's turning. And so there's actually no outward force. And I'm sure just in the language the language I'm using here to describe it, because I haven't like typed this out and vetted it with the physics language, so I'm sure I'm saying something slightly off here or there that it's going to get people worked up. But centripetal is the word that I'd say really any technical physics engineering person would use. There you go. So to really answer the question, yes, as a rule of thumb, on a 250-meter track, and I don't have the math. We have all the math. I guess to answer the bigger question, how do you account for this? It's in a very big equation in a very big spreadsheet that I have, and most people make their own. I know Dan Bigham has probably an even better one than mine. But yeah, there's a couple things happening as you're turning, and the bike wants to go straight. You need this force to, obviously keep it held inward radially. And so we tend to think of this force in G's, G force. And at 55 k an hour, right, so a little below the current hour record speed on a 250-meter 45-degree banked velodrome, you're going to experience about 1.4 Gs. And that's one of the things I think that people don't forget about, but don't know or don't think about in why the hour record is so hard. That, if it's a 16-second lap, every 8 seconds your body is experiencing 1.4 times its own like its own mass, right? And particularly your head, and this, back to your neck, fatty, your head is becoming 40% heavier every 8 seconds. And so you're kind of like weightlifting your own head. That's at 55, and at 60, it's a little over 1.5 Gs. And so you think of like these Derny racers, the guys behind the motorcycles. I mean, they're in some cases they're up in the high, like 1.8, 1.9 Gs, and maybe in some of the the final sprinting laps and things, they're approaching like 2 Gs in the corners. And so your typical rolling resistance calculation, rolling resistance is linear relative to the normal force or the weight pushing down on it. And so, your CRR is actually going to go up by that 40% due to the increased normal load on the tire. And at the same time, and this is one that is oftentimes not fully understood, because the rider's center of gravity is radially inward from the tire contact patch with the track. And so for the rider to essentially maintain velocity, right, around that radius, the bicycle at the contact patch of the tire actually has to accelerate in each turn. And so the other thing that's happening as your CRR is going up is that the bicycle is actually accelerating under the rider as it works its way through the turn, and then stabilizing at the end. And of course, again, in a 16-second lap, you're doing this over and over again about every 8 seconds, since there's 2 turns per lap. So a lot of really beautiful and really gnarly math happening there. And it just adds up, right? It's just this cumulative effect, and it's the cumulative fatigue on the rider. And, and that is one of the things that, we might test a tire, say test a tire on a drum and get one CRR, and then we actually have to bump that CRR as an average up slightly in the models that we're using if we're calculating something like an hour record or a 4K pursuit, because it's not, it's not just riding on a flat, smooth surface. You're actually seeing this variable normal force and variable velocity.
Okay, we have a couple of one-by questions in the queue here. I know this is a touchy subject here on Marginal Gains, because we all know how we feel about 10 cog tooth cassettes. But nevertheless, one-by seems to be having its day these days. A lot more of it showing
That's
up
for
on the
sure.
road, especially. Now, Neil Mackley wrote us. He says he races time trials in England, that is. Good on you, Neil. And good on England, by the way, for keeping the time trial thing going. It's really hard anywhere in the States to find ongoing, organized time trials. So good to see that they're still doing time trials there. He says he has a personal best in the 10K of 19 minutes, 48 seconds, and says he does most of his time trials, that is, on a one-by setup, usually a 60-tooth up front with an 1123 cassette when the course is flat, 1125 or 1130 on hillier courses. Nick is wondering about the narrow, wide front ring. Is it costing him anything over a standard ring?
Ooh, so yes, narrow wide is going to cost you a little bit. We're talking probably sub-watt. We've actually done a lot of testing on this with the lab at Purdue that we work with, and chain friction testing and drivetrain efficiency testing. It's costing you more when you are cross-chaining. And so, if you think of, I would, especially for flat time trial like this, really optimize the cassette, that you want the straightest chain line possible in the cog that you're using the most. And ideally, if you can be, up or down one from that, that's where you're going to see maximum efficiency. And then as you begin to put some angularity into that chain, and particularly as you get, to the top of the stack there, you absolutely costing yourself a little bit. And that's, you can see it in the way those chain rings wear, particularly the wide teeth. You'll notice they pretty quickly, especially if they're like fully black anodized when you get them, you're relatively quickly wearing the anodize off the corners there of the wide section of the tooth. And, I will say at the World Tour level, there's actually some manipulation and polishing and some other things that are oftentimes go on chain rings like that for events like time trials. Because we know that, if you're wearing the anodize off in 10 kilometers, like there's some metal on metal rubbing happening, and nothing about metal rubbing metal is ever fast. And so we put some effort into taking those corners down and smoothing things out, and there's some surface treatments and other things as well. But yeah, no, I think Neil is otherwise certainly on it. I mean, one by for time trial is absolutely the place to have it. Good on you for a 60-tooth setup. The big is better. So it sounds like he's all over it, and I would just, again, really optimize for that most used cog, and really optimize your stack. And I've even set up cassettes in the past where you might run two of the same, start with a 12 and then run like a 13-13 and then that 14 or whatever you're expecting to spend your time in the most, so that you can kind of run right in that optimal, perfectly straight chain line part of the cassette.
Yeah, I think Jason Smith at Fishkin Facts also looked into one by and potential losses, and same thing there, Josh. He found that it wasn't so much the teeth and the way they engage the chain. I'm talking about the front chain ring and the narrow wide setup there. It was the cross chaining that was really messing with you. Anytime you got a little off your chain line, especially if you went to that big cog, you were really starting to lose watts. And of course the 10 tooth, which we've spoken about here before, you really want to try and stay out of that thing, because you're just chucking away watts in that thing there. But it really does feel like, one by is starting to have its day, question mark, on the Pro Tour riders. And these are largely Jumbo-Visma riders who are on SRAM product now. They have kind of pushed the envelope, really pushed the one by narrative. SRAM has, at least. Although you can run a Shimano setup with one by. I mean, they make GRX. It's one by. You could get the gearing should you want it. We just don't see a lot of Shimano pro riders doing it in time trials or anywhere else. But certainly this past summer and in the spring at Roubaix, we saw Wout van Aert ran one by. So did Marianne Vos. She ran one by at the ladies Roubaix. In the Tour, the winner, Jonas Vingegaard, a couple times he was on one by. I think one by got its most notable, I don't know if it was good or bad press, when Primož Roglič was in a climbing stage time trial, and he actually dropped his chain running one by. I don't know if that was good news or bad news there for the case of one by. But has the narrative changed with one by, Josh? How do you are the Pro Tour riders leaning towards this, asking for more of it, finding that it's working better for them? Where do we stand now with it?
I'd say we're a little all over the map. I mean, it absolutely has its place, and I think having been one of the people who was in the room when SRAM was really developing this for mountain bike. I remember there's like a guy at SRAM, Ron Ritzler, who is a super guy. He and I butted heads on a number of things, but I remember him talking about one by for mountain bike and thinking like, oh God, Ron, you are crazy, man. Like, mountain bike is the wrong thing. Like, one by should be a triathlon product, and then maybe road time trial and taking it that way. And of course, he's going, oh no, you can, like lose the front derailleur and change the pivot points and, all the stuff with the front, that really opened my mind of like, oh, it's less about the drivetrain and more about, if we don't have to have all this stuff on the mountain bike frame, what could we do there? We could put extra pivots and all sorts of stuff. One of the wrongest the other thing that Ron brought back was the dropper seat post. And I remember like, oh God, Ron, we had this, remember Height Right, like 1989, like nobody needed it. And, man, was I wrong about that. Right? And so he's probably proven me more wrong and to a greater extent than just about anybody from my career. But, I think it's like our favorite answer to everything here at Marginal Gains, it depends. And, there are absolutely places where one by is the better setup. And then there's absolutely places where it's not. And, I think one of the challenges we have around pro racing is, companies kind of historically are just pushing the pros to ride what the companies are making. And then you would at times get the mechanics, I think of like Faustino, who was Contador's mechanic, he loved to sort of freeform, he's like a jazz player, and you'd show up and be like, what the hell are you doing? Like, oh, I'm taking this apart and mixing up the components and throwing half of them away and using aluminum bolts and, like, oh my God, somebody's going to get hurt. And so I think, we're all in this sport because we like product and we like to tinker and we like to muck about. And I think we're all still learning where the optimal place for these things is, right? Mm-hmm. I think certainly what you saw like with Jumbo-Visma at the Tour this year and knowing some of the mechanics and stuff around that, I think, they definitely were feeling a little bit of pressure to use the one by maybe in some places that they might not have thought to do that themselves, and not saying it was the wrong place. But, you know, there, you think of the whole kind of industrial complex around a team. You know, it's like Roglic's drop chain. You know, that's not a one-by problem. That's almost certainly some sort of a setup problem. And, you know, so it's, you know, how attuned, how competent, how comfortable, how on top of everything are all the details and all the mechanics. And, you know, I think like anything else, you know, when you start to add variables and change, that oftentimes opens up little risks too. You know, if all the bikes are the same 2x11, then every bike gets adjusted the same way. Every problem has the same answer, right? And then when you introduce a new drivetrain, that's a whole new complexity. And so, you know, I think there's things like that we just all have to be aware of. But I think for me, I mean, if I were time trialing, I would absolutely be on a 1x, you know, and a lot of the athletes that we work with, we put them on 1x for, you know, certainly prologue stages and other things where it fits. And then I think from there, it's just making the right choices about, you know, what cog are you using the most? Well, what, you know, and what is that? Is it a 10? Because then you need a bigger chainring. You know, things like that. So, yeah, I guess as always, it depends. But I think for what we're talking about here, particularly around time trialing and relatively flat time trialing, heck yeah, that's run your 1x. That's definitely the way to go.
Yeah, Fatty and I have at times on our other show, our Leadville show, we have tried to push the opposite of 1x there, and it's always a little touch and go, right, Fatty? I mean, we tried to say on our show once in a while that, hey, 2x at Leadville, since it's so long and so varied and so road-like at times, 2x at Leadville is an absolute viable option because you get this huge wide range. You can really stay in the middle of your cassette. We get a lot of blowback, though, from the folks saying, no, put a 28 on and a 1052 or whatever and ride that way.
Right.
I kind of roll my eyes like, boy, you folks need to really start checking into where your watts are going. You won't like what you see when you're in a 2810. It just gets kind of ugly. So, yeah. But it's hard when something has grabbed a hold like that, and everyone buys in. Trying to say no, there's times when you don't need that. Gets to be a difficult sell.
Yeah.
A
listener. I was going to say a listener sent in a message into our hotline, 317-343-4506, in case anyone else wants to memorize that, proposing what I think might be the perfect practical case for the 1x Florida. And I checked, and he did. His area code was from Florida. He said, would a 1x drivetrain be more efficient in a pancake flat coastal place like Florida if you've got a full-size chainring, 50-tooth, 56-tooth, and an 1134 12-speed cassette, you know, versus your 5236? He says he understands that you are not a big fan of 1x, so this is one of our people. But, I mean, in a place that is flat, I mean, like this, it does seem like, okay, yeah, there you might, you know, 1x makes pretty good sense.
Yeah, absolutely. I think the one thing to remember, and, you know, living here in Indiana, it's where we might as well be Florida, right? Without the beaches or the hurricanes. But the one challenge I always have with 1x, particularly on the road, is those gaps between cogs in the cassette. And, you know, I think you know, on like your mountain bike, you're less noticing those kind of larger jumps because of the variation in the terrain. And I know personally, one of the challenges I have with the 1x, you know, in my own riding is I just feel like I have a lot of situations where you just can't find the gear. You know, now, and I think we've said this before. You know, I grew up in a world of, like, you know, step gearing and you know, straight blocks and all of that. And so my body's probably just a little bit tuned to something different, but it just drives me nuts at times where, you know, you like shift up, shift down, shift up, shift down. You're like, damn it, I need the thing in the middle. And that's really what I mean. You know, my bike that I ride here. I mean, I literally run a straight block cassette of my own creation, and then I've got like a 52-36 front, and you know, it's way more range of gearing than I can ever need, and you know, I probably truly do 95% of my riding in the big ring across 4 cogs in the rear, maybe 5. Because it's so flat, but every one of those is a one-tooth jump from the other, and so you know that for my own personal riding or method or whatever you want to call it, I find that to be really pleasurable, and I probably shift the front chainring twice in a month, if that, and at the same time am really pretty much never using the full. The full range of the cassette either. Right. So, but yeah, if you don't mind the jumps, I think, you know, one by, I mean, certainly from it's lighter, it's cheaper, it's easier to maintain, it is easier to set up, you know, especially if you're doing your own work. I mean, I think, you know, front derailleur's probably the hardest, you know, next to some of this disc brake stuff, probably the hardest thing to really get right on your own bike when you're doing your own work. So, you know, yeah, if you don't mind those jumps, I think one by in Florida, match made in heaven.
Yeah, and I think what you're saying here, Josh, is no matter what terrain you're on, whether it be Leadville or a flat time trial in the Tour de France, whether you're one by or two by or even triple, you're always trying to be in the middle of that cassette as much as possible. You don't, even if you have a 12, right, a 12-25 cassette, you really don't want to be in the 12 if you don't have to be. I mean, you'd rather be in the 14 or 15 or right, as much as possible. Those are the sweet spots, and it's about finding the right combo to keep you as much as possible in those sweet spots.
Yeah, absolutely.
Okay, here's one that came in via the Marginal Gains hotline. We love that hotline. You can call it, text it, 317-343-4506. Jim has an intriguing question about speed wobble. He says he's listened to all our podcasts. Especially loves the deep dive engineering talk on all things cycling. On to his current near-death experience and how to fix it. That's the question at hand. He says, I was riding recently on a gravel bike, descending on a road section around 35 to 40 miles per hour, and my bike started wobbling like crazy. I've raced mountain bike, road, track, and cyclocross. Descended on other bikes past 60 miles per hour. I feel very comfortable on bikes at speed, but this was terrifying. My bike is a well-made, modern steel frame with a slightly long top tube and reach, 70.5 head tube angle, a carbon fork with a 50 mil rake, 60 mil deep arrow wheels, and a tire insert. I ride nice tires. I've had it happen now on different tires. The wheel is well balanced. For the life of me, I can't figure it out. This only happens on steep descents, above 10% grade, and at moderate to high speeds. I can't get it to happen on shallower grades, even at higher speeds. Here are the questions. Is the center of mass moving over the steering axis too much? The effective mechanical trail altering in relation to weight distribution? He says I can try a fork with a taller axle to crown to increase fork trail, or get a different headset that allows me to change the head tube angle of the bike. Maybe take out my tire inserts to decrease gyroscopic forces. Feels like a lot like hop bifurcation. Sounds like it. Comes on rapidly. Have to almost stop to get it to resolve it, and still remains a mystery.
Oh, God, yeah. You just hate hearing that, and we've all been there, right? I mean, they're just terrifying to experience. Yeah, it is hop bifurcation, and, you know, I think we've got a great episode on that. But the long story short there is you know, the hop bifurcation is a point that you cross where you go from having a stable equilibrium to an equilibrium which is actually unstable. And so, like, once you've crossed that hop bifurcation point, the new equilibrium is the wobble. And I think that's the thing that just makes these so terrible, right? Is that the bike, once it starts wobbling, like it wants to wobble, like that's its thing. And that's why you really have to almost get it to a stop to resolve it. And there's some hysteresis effects and some other things in there. The biggest correlation in a bicycle to this speed wobble and to this hop point is the lateral stiffness of the top tube, and that's because the essentially your butt anchoring the seat post and sort of the seat tube of the frame, that becomes the pivot point about which this lateral oscillation happens, and the way that you push the hop bifurcation point to a much higher speed is to actually stiffen that upper part of the bike. And so I think, when he says, it's got a longish top tube, it's a steel bike, it sounds like we may just be looking at a bit of an underdesign on that lateral top tube stiffness, which is like the worst possible answer I can give because of all the other stuff you can change. That's something that's not easily or affordably changed. There are other things you can do to try to move that bifurcation point to a higher velocity. I think some of the things that he's talking about, a taller axle to crown, that some of those things are I know some people oftentimes like try to raise their stem. That essentially is keeping your weight further back on these steeper descents, right? So I think as the descent steepens, your weight is shifting forward and changing the dynamics of the system. And so moving that up, you can move it backwards. Sometimes we've seen people, a slightly heavier tire, a lower tire pressure will actually add contact patch. And the more contact patch, the more damping within the contact patch you're likely to have. So I would say, I would definitely look at, especially since you're running inserts already, try lowering that tire pressure, 5% and then maybe 10% and seeing if it repeats. Again, you're not going to eliminate this, but, maybe you push it from, 40 miles an hour to 45 miles an hour. And if you're not going 45 miles an hour, it doesn't matter if the bifurcation point is just past the max speed that you're going. Things as simple as, I remember a Trek had made these vibration damping bar end plugs probably 10, 15 years ago. And I know a number of people who had experimented with those in trying to push the bifurcation point up because you're changing the mass of the system, and that absolutely does have an effect. So something as simple as that, adding a little bit of weight, slightly heavier tire, just trying to shoot through some of your other options, but ultimately, like at its most fundamental level, unfortunately, the real challenge or the real kind of root cause of this problem is going to be that top tube stiffness.
That's a tough one, yeah, because that's the hardest thing to replace almost, right? I mean, I had two bikes that I owned, both with the speed wobble problem. They were both lugged. One steel, actually I still own one of them, the other I sold. And there was no getting around it. They're just going to wobble, right? Josh, the wobbles, are they always initiated through the front wheel, or can they be started other ways? Can the wobble be initiated through a gust of wind? Any other way?
I mean, there's certainly different kind of triggers that could push you past that point. One of the things in the literature that's quite interesting is the temperature outside, because the speed wobble tends to have a very similar natural frequency to that of like human shivering. And so as you get cold and you tense and you're closer to shivering, you're actually more likely to become kind of a bit of the negative feedback loop in the wobble. So, there are certainly external factors, the road surface roughness. If you're hitting washboard and that washboard is a match sort of in that or close to that natural frequency of the speed wobble, right? That may be enough to push you kind of over that line. And again, like I said, once as we've all experienced, it's just so unfortunately not a line that you cross and then can pull back from and solve, right? It's like you cross the line and then it's really hard to get back the other side of the line. It would be different, right? If, at 48 miles an hour you speed wobbled and at 47 you didn't, and you could feather the brakes a little bit and it would go away. Mm-hmm. Unfortunately, it's just not that type of a problem. It would be ideal if it were, right? You could just use a little more brake and you'll be fine. But that is what makes it just such a dangerous and just maddening problem to solve. So, but I will say, if you really want to dive, there's some pretty good literature out there. I think University of Delft in the Netherlands had written some stuff. I know Lennard Zinn, who we've had on the show, is incredibly well versed in this, partly because he's such a big, tall guy, and he really was one of the first to kind of take the advice of some of the literature that's out there, and he started building frames for himself using the biggest down tube he could find as his top tube, and all of a sudden the speed wobbles disappeared from his 70 centimeter bike or whatever he's riding. So it's definitely a problem for taller riders. It's definitely a problem on thinner and lighter weight tube sets, and you can probably tweak it around the edges with some of the other things that we talked about, some of the maybe a little bit of fit, but largely I would say mass related things at the front end of the bike. You might be able to push it a little bit past the max speed that you're likely to experience on this particular descent or this particular grade. But your real true long-term solution here, probably involves something like a new bike, which, is not a bad thing. There's two ways to look at it, right? On the one hand, I really hate to be offering that. On the other hand, you can
new bike day.
Look at your wife and be like, Josh said it's new bike day, and
sorry, I wish there
I'm happy
were
to take
another way.
Yeah, I'm happy to take the fall for that one on your behalf.
So noble.
Yeah, you're welcome. You're welcome.
I got another question from a listener on hard braking and steep descents. This is a little different. This comes from Dan in Washington, D.C. He, of course, texted our hotline 317-343-4506. He says, "Hey guys, versus rim brakes, can disc wheels have a lag during hard braking while the spokes load up with tension? I have a nice set of race wheels I love for 95% of road applications, but they feel hesitant to slow, that is, terrifying, under hard braking conditions."
Oh, no.
Specifically,
that's a bad word.
hard descents. Yes, terrifying is bad. Is it possible that some wheels suffer from this more than others?
I really like this question. I'm going to have to go look at some data. So, possibly, I'll have to talk to some people to get some data. In a traditional, appropriate wheel build with, cross spokes, the windup here really should be less than what is perceivable by the human. Thinking that through and trying to think of some of those curves that we see. You definitely see. I think of Mavic started it. We did it a little bit at Zip, but where we were doing like radial drive side spokes to get more spoke angle and crossing the non-drive side, and there's only about 1.5 degrees of so-called wind-up, but riders can feel it. And interestingly, when you test them blindly, they never say it's wind-up in the wheel. They always say like, "Oh, that wheel is heavy. Like it's got a lot of inertia. It accelerates slowly." And what's interesting is because those are very elastic deformations, the wheel actually doesn't accelerate slowly. It just is perceived as doing so because of this slight, like couple fractions of a second time lag. I'm imagining that's probably about the same thing we're feeling here, and I'm trying to take my personal experience around accelerating lag and then looking at it as decelerating lag. You know, we're talking probably somewhere on the order of a tenth of a second lag in a jump, acceleration jump in a wheel like that. You know, you quadruple the forces in, call it hard descending, or you know, you double them and maybe it's 2/10. Your brain is going to play games with you around this lag, but I think when you actually, like when we look at you know, race car vehicle dynamics like data tracing, your brain perceives some things as being much, much bigger and worse than they are. You know, that tenth of a second, 2/10 of a second, even if we double it, lag, that's probably not having that huge of an effect on your actual braking and control of the bicycle, but it definitely is going to play crazy games with your brain. So I would say, and of course, I'm using a worst case scenario, right? A radial drive side where you've got that side of the hub winding up, transferring across to the other. You know, for a truly properly built and designed wheel with disc brake, I cannot imagine anybody's making anything that has even a fraction of that sort of torsional deflection under braking. And then, of course, you've got the flexibility of the fork leg, you know, which is something that a lot of riders can feel, you know, particularly those of us who were around for the really early ultralight carbon forks. You know, think of those like Look HSC series carbon forks that were 300 grams, you know, back in the late 90s or mid 90s. And, you know, you could hit the brakes hard enough and see the fork tips jump backwards about 2 centimeters. It's a similar effect, right? And I think it's probably a lot more your brain not being fully calibrated for what just happened than it is about the overall performance. You know, I think once it reaches a homeostasis, you know, call it a couple tenths of a second in, your braking force is same as what it was. And a similar analogy I would use here, and this is an interesting one, you know, when you're working with like Le Mans prototype cars and you've got, say, different drivers from different series, the paddle shifting is an interesting one. You know, you've got like the guys from Formula One who are using true like sequential gearboxes where, like, when they bottom the paddle, the gear, it's in gear, right? The shift has occurred. And then you've got folks coming from series where they have like electronic hydraulic gearboxes where it's more like the video game. When your finger bottoms, that triggers the switch that then initiates the gear change. And, you know, on paper, I mean, these are sub-tenth of a second, but when you put it in the hands of a driver, you know, Formula One driver driving an hydraulic or electronically driven mechanical even gearbox, I mean, for them, it's that tenth of a second is a lifetime, right? And you'll find that they bounce the thing off the rev limiter like crazy because they're shifting when the shift needs to happen and not just before the shift needs to happen. And it's one of those, you can look at it in the data traces, and, you know, I've definitely had moments where you're like, you know, it's 0.06 seconds delay. And they're like, yeah, but I bounced it off the rev limiter 3 times during that. You know, like the brain is just tuned to that number. And so like a lot of those endurance cars where you've got different drivers of different series, they'll actually put a knob on the steering wheel that could be like a shift delay that allows the drivers to sort of like tune the car to feel a little bit more like something they're used to. My guess or assumption, without having access to a rig where we could really look at this, is that that's probably much more what's happening here than it actually, you know, slowing down more slowly due to this lag.
That's why I recommend my solution, which is be oblivious. I know lots of riders who are really good at noticing tiny little differences, and I start to notice the difference in ride quality, you know, when I'm like 8 PSI too low, maybe 10, maybe 20. If I'm riding on a flat, I do at some point notice, that I am riding on a flat. Hottie's shaking his head because he knows this is actually true. I can ride through anything, though. I mean, it is nice to just be unaware of your environment as you ride.
I was supposed to be feeding Fatty at Leadville this year, and I made a huge error in my feeds. I forgot to put his hydration pack on as he headed out for the largest climb of the day.
Didn't notice for 20 minutes.
He didn't notice for 20 minutes. Didn't notice. So, yeah.
Be oblivious.
Yeah.
That's a skill. I have to say, yeah. I mean, I have worked with both types, and you've got the Eddie Merckx type of, I've got to adjust my saddle 37 times, and every fraction of a millimeter is huge, and I've had other riders literally 20 minutes into a training ride, like, you're on the wrong bike. Like, oh shit, I am. Like that saddle height's like a centimeter off. Like, yeah, I didn't notice.
Yeah,
I
have ridden just for fun a couple of times with Levi Leipheimer, and he would make quarter millimeter adjustments to his saddle height, multiple times during a ride. I have ridden my mountain bike where for whatever reason the seat clamp wasn't sufficiently tight or something, and about the time I've sunk an inch, I start going, my knees hurt. But I'm not a quarter millimeter guy. I will say that.
Yep. Man. Okay, some dude named Hottie wrote us a question here about the new wheel size. Hottie says he reads way too much cycling product news for anyone's good, so he wanted to get Josh's impression of this new wheel size. WTB, Wilderness Trail Bikes, good California company, recently started showing off a new wheel size it calls 750D. Work on this project has been going on for a couple years, but they recently went public with it, with the size 40 WTB Nano mounted to a 750 rim. Essentially what you get there is a tire that is about as tall as a 29 2.3 mountain bike tire. WTB says in the field, the 750 wheel has proven to be more stable, better rollover qualities, kind of the same stuff we heard when mountain bikes went from 26 to 29 inches. Who's it for? Well, WTB says maybe taller riders like Lennard Zinn on really large frames. WTB says it's looking for buy-in from frame makers and riders before deciding what to do with this experimental size. Josh, as someone who spent a good portion of your life studying and improving wheels, I'm guessing you've heard about whether or not the good old 700 is good enough, whether there's a more optimal size out there. What are your thoughts? Can we be doing better than the 700? It depends. I know. Wait, let me say it for you. It depends.
My groan. I'm not sure. I'm not the audio level of you guys, but I need some help making sure that my groan is fully felt in the guts of the audience. Work your audio magic on that. But yeah, I actually heard about this. This was coming at SBT Gravel 2 weekends ago, and I wandered down to see my friends at Moots, who I just love, and like, did you bring a piece of wood for me to bang against my head? Monty Python style. Come on. And then honestly, at some level, was like, joke, please, joke. Oh God. Okay. Having gotten past all that, yeah, I totally get the allure of optimization problems, of which this is one, right? Is 700C, known in my world as 622 millimeter. Is that the right size, the perfect size? Who the hell knows, right? I mean, you think of the test matrix you would have to put together to really understand this. Okay, we're going to make from 571, which is 650 C, all the way up to whatever. I don't even know what 750 D is. It's actually why I kind of thought it might be a joke. The C in the rim sizes for crochet for a hooked rim. I'm not sure where the D came from. I assume it was like the next letter. And I'm not sure where the 750 came from, because maybe that's like desired tire outer
Yeah, I think 750D
diameter.
is 660. That sounds about right. Yeah, 660 millimeters.
660 millimeter
Yeah,
bead
right.
seat. Okay. Yeah, I mean, you could make a test matrix and probably do them at every 2 and find that, for riders at this height, this is optimal, and riders at that height, and at this roughness, this is, oh my God. I mean, the sad reality is you really just need to pick something, because what really matters at the end of the day is having something that all the tire companies can get behind and then can compete with each other on, because that's where the performance really happens. I mean, we see, from 26 inch to 29er is a pretty big step. But even that, like for like, if you have relatively equivalent tires and relatively equivalent riders, it's just not that big of an advantage. It's just not that much faster, right? And then you look at road, where we convinced ourselves for years that the smaller wheel was faster, and of course it wasn't faster there either. Yeah. It is so easy to convince yourself that this is the thing that matters. And, it's obstacle rollover and the diameter and this, or it's casing deflection, or truly the thing that we need is stability, so you can have as many manufacturers as possible competing to make the fastest tire possible. And the only way those companies can justify those capital investments and those R&D development risks is in having some stability to know that, you're not going to pour, $250,000 into something that could be obsolete in a year or in 2 years. And so I think that's the source of my deep groan is that, I could care less what diameter the wheel is, plus a centimeter, minus, it doesn't in any way matter to me. But every time you add an option, you are just decreasing the pool of development dollars, and the willingness to take risks of the companies that we need to be doing the development and taking the risks on these. And so I think, I look at projects like this as a little bit of call it a siphon. We're just like, it's a super interesting question. I totally get the allure of falling in the rabbit hole on it. But like on net, it's guaranteed to be nothing but a loss long term for the industry and for the riders, because it and certainly history has taught us it's basically guaranteed to be, money ill spent compared to where we could be spending it.
Is there a technical reason? Is there a optimization reason why we've landed on 700? I mean, it seems almost random. Like, we've seen all kinds of sizes through the years, from the penny farthing to the 26, 20-inch. We've had 27.5, 650B, 650A, right? I mean, we've had 36-inch wheels. Why is 700 really the sweet spot? I think was what somebody into optimization, into marginal gains would ask themselves.
Oh, I'm sure that it's not. I mean,
Okay.
you look at the ETRTO or ETRTO charts. I mean, yeah, my God, we've had, you just have to go back to the 80s, right, where you had Schwinn doing all of these things in inches,
Right.
right? And anybody who's ever worked in a bike shop, you're like, oh my God, like what is 27 by 1 1/4 is totally different from, it's a different diameter than 27 by 1 3/8, or whatever those some of those numbers were. Oh, well, that's a Schwinn, and their 27-inch was measured differently than everybody else's 27-inch. I think 700C, the 622 millimeter diameter, I think that it has probably come about as, it's what the Europeans were doing. At a time when you think of, the bike racing boom of the 70s into the 80s, you've got the Italians who far and away have this currency advantage of export. And so, it could have been the British, but their currency was too expensive. It could have been the French, but they're too French. And they insist on mixing like metric diameters with like British thread forms. and TPI specs, and so like that always just strikes everybody as painful and odd. And so, I think if I had to guess, and hopefully there's someone who knows the history better than me, but my guess would be that this was the Italian export advantage due to the lira, essentially guaranteeing that, the Mazzis and Colnagos and Pinarellos and became the de facto race bike of the era. And everybody really kind of had to follow suit. And you had Schwinn, who had their own standards, but that was really more of a way that they guaranteed that Schwinn bikes would get worked on at Schwinn dealers and that only Schwinn spare parts would be sold for those Schwinn bicycles. And that business model ultimately began to break down for a number of reasons and some family infighting and other stuff within the whole Schwinn thing. And I'm sure someone's going to come and knows the history way better than me on that. But, that all kind of died. And I think we came into this period of relative stability. And I think the original mountain bike wheels were just road wheels that were rolled smaller to kind of, I think, the same idea, like try to keep the diameter of the larger tire relatively similar to a road wheel. And if I had to guess, I'd say there's probably some things in there around toe overlap and just general frame geometry that, if we have a wheel that's relatively this diameter, we can put it in a frame with more or less this geometry, and we know that it's going to ride more or less like this. And we're not going to have crazy toe overlap, and we're not going to, these other things. And then I think you just get the install base of the tires, and certainly, I think you just have to look at road and time trial and triathlon to see the benefit of having a single tire size. 15 years ago, you still had 650C, which is 571, as a competitive and popular triathlon wheel size. And even a little bit before that, you had the whole funny bike thing with 650 front, 700 rear. And all these companies now have to make twice as many tires. And are you going to develop your 650s along this with the 700s? And as a result, we just had less choice. And the tires we had weren't nearly as good as what we had today. And so as that starts to die, and then, tubulars start to die, and they can begin to focus more on clincher growing into tubeless, you just see that concentration of development dollars. And I do think personally at some point you just have to say, it's good enough. There's, and again, you could quickly build a matrix and run this, but what is every millimeter of diameter increase? What's the benefit? And it has to be a diminishing returns, because if it weren't, we could take the 36-inch wheels of today and you would go out and ride them and be like, my God, they're 20% faster, right? Except they're not. Like a 36-inch wheel is really cool looking and it's a giant monster, and you go ride it and you go, wow, that really feels different. And you look at the data and go, oh, how much faster was I? Well, the same. Okay, well, shit, if that didn't make a difference, right? What's a centimeter or two going to make? So I think that that certainly would be the way I look at it, which is probably a mashup of a very commercial reason and a very R&D development cost reason. But yeah, I think we can without a doubt say that 700 can't possibly be the right answer, because we just made it up and nobody's ever really studied it. But I think we also have enough data points out there to go, yeah, but directionally moving that around also doesn't really seem to do anything that provides any obvious benefit. So
you're saying there's a chance?
Yes, exactly. Exactly. I mean, I think the other way to look at that is like do the thought experiment of they do the 36-inch wheel, and all of a sudden, like, nobody can compete with people on 36-inch wheels, right? Like that product begins to grow, and you've got this underlying thing of like, oh man, Bob showed up on the Sunday ride on 36-inch wheels, and nobody can hang with him anymore, right? I mean, that would change everything, right? You would go like, oh my God, bigger that's a huge deal. Like, whoa, what's the right answer? We got to do this. And, the reality is a guy shows up with wheels that are, whatever, 8 or 9 inches larger than yours, and it doesn't really do anything. So, for me, I think is there some really minuscule marginal gain in there somewhere? Probably, right? And we could spend a $1 jillion and discover what that is. But I still, if you had 6 universities, do 6 PhD thesis papers on this, they'd all come up with some slightly different number, and then we would just have more to argue about. But I guarantee, again, because we know the numbers from the extremes, those slicing hairs in the middle, they're just not going to be that big of a difference.
I'm just trying to imagine how I'm going to throw my leg over a bike with a 3-yard wheel. Or 36-inch.
Yeah.
I guess 36 inches is 1-yard wheel, but that is still a big wheel.
Yeah, I mean, they're really cool. I mean, I have to say, God, it's been 10 years ago now, but I remember meeting the guy with the first I ever saw 36-inch wheeled mountain bike at Interbike in the that outdoor ride thing in the desert that they used to do. And, it looks cool. You get on it, it feels different. It's fun, right? And I look at that and be like, oh, yeah, that's super duper fun. But I think when you're just talking pure performance, you just got to take that. It's a lot like, the stiffness, right? Some of these things, we say, okay, you doubled your bottom bracket stiffness, and what happened? Nothing. Okay, so why are we still talking about this, right? like if you double it and nothing happens, then why are we so obsessed with making it 5% better or 7% better? Like, we can double it, and it doesn't do anything. And I just have to think. And again, this is totally one I would be so thrilled to be proven wrong on this. Like, somebody builds a test rig or some PhD candidate somewhere, puts this theoretical thing into practice and comes back and goes, oh, wow, yeah, no, look, there's like a saddle shape in the performance here, that there's like an actual peak minimum, like rolling resistance optimization point that just happens to be at 69 millimeters or whatever that is. And we've theorized it and we've tested it, and it looks to be true. You go, oh, wow, that's really cool. And that would explain why the 36-inch wheel isn't better, right? It's a saddle shape, so you've got a peak minimum somewhere between here and there, and looking at the extremes isn't the way to solve that problem. I highly doubt that's the case, just based on experience. But I mean, if somebody were to prove that, like, I'd be the first guy in line with like, oh, let's get, let's try it, let's see what it is, or let's put some money into making super fast tires that fit the quote unquote fastest diameter wheel. But I just think it's insanely unlikely. And in the meantime, like I said, it's just siphoning dollars away that the rest of us will otherwise potentially benefit from at some future point in time.
That doesn't even sound like it depends. Sounds like the most definitive answer you've ever given. Wow.
But I could still be totally wrong. That's what makes this so fun.
Absolutely. I think that is a good point to say. Let's go. I'm going to take that again. All right. How do you jot that in his notebook? I think that is a great place for us to leave this episode, guys. Again, congrats on getting to 1 million downloads. Probably 1,000,001 now. 100 episodes where this is 101. That is a whole lot of little things. And now on to the next 100 and the next billion downloads. I'm setting a target, setting it high.
All right. What we forgot to do as we climb this podcast mountain was count how many questions we have bounced off Josh.
Oh.
Probably not 1 million, but hey, you can help us get there. We want to hear all your questions, and here's how to submit. Text or call the Marginal Gains hotline, 317-343-4506. You can also comment on this or any episode at marginalgainspodcast.cc, which is where you'll see links to all the platforms to listen to this show.
All right. Well, thanks again for the 1 million downloads, even if 700,000 of them were fatty.
You're welcome.
But thank you for that. We really appreciate you, and we will be back soon with more questions and answers. So thanks again for listening to Marginal Gains.